Hi all, myself Melvin Varghese, currently working as data engineer for an IT firm. Today I would like to present you a project which I recently worked, that is data pipeline using Snowflake External Stage using AWS Lambda service. In this video, I would like to cover what is this project about, technology used in this project, live demo. I'll be explaining another approach for external stage using Airflow. After that, if possible, I'll be covering basic code walkthrough. Agenda of this project is learning data ingestion to Snowflake using external stage, automate a pipeline to load data to Snowflake, implementing incremental load of data. Incremental load in the sense only delta changes are ingested to the target table. To implement incremental load, metadata-driven approach is taken. I have given detailed explanation regarding metadata approach in Snowflake internal stage pipeline. To know more about it, please refer the video. Link is provided in the description. Technology used are Python, Snowflake, MySQL, and Airflow. Python is the core language in this project. Snowflake is the target or destination table. MySQL is the source database. Airflow for the orchestration. This project will leverage AWS S3 as an intermediate storage solution, utilizing AWS Lambda to load the data to Snowflake, performing incremental data loads. In this pipeline, MySQL database will be migrating one table, that is Amazon Books. Columns for the Amazon Books are book ID, book title, book amount, book author, book rating, book link, business date. And the primary key for this table is book ID. For external stage data ingestion, we will be having a config entry in source database as well for incremental load. This will be a config entry. The table name is table config. Same way which we have done with Snowflake, we'll be having a separate config entry in the MySQL as well. So this is the table, the database created config, and inside config one table is created with the same table name and last extract date. For generating the source data, I have developed another pipeline using web scraping. If you're interested to know how the data is generated in MySQL database using web scraping, link is mentioned in the description. Please do refer the video. For external stage data pipeline, a DAG is developed to upload data to S3 bucket. To do the incremental load, we use metadata approach to upload the delta changes data to S3 bucket. This DAG has two steps. First is upload data to S3. Second step is update config. In the first step, it gets the delta changes data from MySQL database, uploads the data to S3 bucket. In the second step, on successful upload of data to S3 bucket, the config entry which is stored in MySQL database is updated. In target data workflow, once the data is loaded in S3 bucket, the AWS Lambda service is triggered and the respective script is run, where it is connected to Snowflake using Snowflake connector Python library, and it does the incremental load, finally updates the config table. This script consists of all the steps like getting the last extract date, loading data to external table, load the data to the transient table where it consists of merge into command, finally updates the config table on successful loading of data. So this all the step is included in the script, Lambda script. Again, we are following the same what we had followed in internal stage pipeline for config. Here we have created database name Amazon Books External. Same table name config having last extract date and table name columns, and same table name primary key. And these two tables are used for incremental via metadata driven approach. The only difference, if you see, it's the same as it is which you followed in the internal stage table. Only difference is database name is Amazon Books underscore external. That is it. Now let's see the Snowflake table DDLs. Here we are creating an external stage. Create or replace stage. The external stage name is Amazon Books underscore ext underscore stage, where you are defining the S3 path. See over here in the this is the S3 bucket. Inside Snowflake folder, we have a directory, sorry, Snowflake directory. Inside it, we have database name, Amazon books underscore external, and we have the table name. Inside it, all the data which is stored will be linked to external stage. And we are defining here file format, IPCSV delimiter, option enclose, skip header. And we have one more field, that is storage integration. We have defined here a storage integration. Why do we need a storage integration? As we are loading the data to S3 bucket, external stage needs the necessary permissions to access the data into the S3 bucket, as this S3 bucket is not public. To give the necessary permission to S3 external stage, storage integration must be created. So storage integration is nothing but which stores the ARN, which is having the respective permissions. This needs to be created and assigned to it. So this could be created in your account where this S3 bucket is loaded. So in this account, you need to create it. So that is where the store integration comes into the picture. So now we can list and see how many data is there in the storage. I'm at external stage. So inside this path, you'll see which is already executed. So few data already present in the external stage in the respective S3 bucket. Now you see, let's see, we are creating an external table. So you'll see here all the columns which is there from the source. But you'll be able to see a new column, that is file date partition. And this is nothing but a partition column which we have defined it over here. And now we need to know how did we define this. So we used it by metadata file name. So let me query and show you what is the value of metadata $file name that is linked with the Amazon book external stage. Let me execute this. So when we execute this, we will get nothing but S3 bucket path of each files. So you see over here, we have defined as well. When you see the external stage, you'll have the same file name path. So yes, it's Snowflake, Amazon book external, Amazon book, somewhat that's the same. Snowflake, Amazon book external, Amazon books. So what it does here is, it tries to fetch this metadata file. It splits by the slash, and it's trying to get the fourth element. So fourth element is nothing but first, second, third, fourth. So fourth element is nothing but the partition folder. So inside every partition folder, data exists. So for this column, we are assigning the partition folder value. This is nothing but the business date, the respective business date we are assigning. So the file date partition is storing a numeric value, which is nothing but a business date, which we are casting it to integer. Okay, that is what. So now you could ask a question, why do we need a partition in an external table? If you have a partition external table, imagine a scenario where external table is very huge. So if you're using a filter using a partition column, it optimizes and it scans the respective partitions only. As a result, performance increases. So whenever we are creating an external table which is very huge, it is always recommended to have a partition column. So that is the main reason which I created over here. As learning point of view, I'm just created here. Okay, so I'm using the same business date. I'm creating the partition. If we use filter using the partition column, that query will be much more efficient. So using metadata $file name, I am getting the particular partition column value. Okay, yeah. So this is where we are creating the external column. Now we are creating the transient table, where I hope you know what is transient by now. So transient table have 1 day of time travel with the Snowflake. So it also has, so Amazon books. Now these are the tables which columns which we have: book ID, book title, amount, author, rating, link, business date. Along with it, one more new column got introduced, that is nothing but file date partition. So this is the table which we are going to migrate from external. Amazon book external will be migrating data to Amazon books, sorry, ingesting data to Amazon books incrementally. Okay, and for the external table, you need to have location assigned with the stage location, external stage location. So external table will be all the time pointing to external stage only. So that is where from there we'll be incrementally loading the Amazon books. Now, as usual, you see we'll have a config entry. One is table config entry where for the books, what is the last extract date? And next is primary key for the respective table. For Amazon books, the primary key is book ID. Now let's jump into the demo. Now I have logged into the Ubuntu machine where I had installed the Airflow and developed entire data pipeline. So I have developed the DAG name as Snowflake External Stage Amazon Books DAG. So as I already explained you in the source data workflow, here there are two steps. One is upload data to S3. Only the delta changes is upload to S3, and on successful update, the config is updated. So let me show you what are the data there in the source. So let me open the MySQL workbench. So let me show you this. So first, let me execute what is the last extract date and show you for the respective table. So you see over here, I've created a database known as config. Inside this config, there is only one table, that is table underscore config. Okay. So let me show you what is the last extract date for the Amazon books in the source data. As I execute, you see the last extract date is 1st March 2024 and Amazon book. So this is the last thing which is uploaded to the S3 bucket. Now let me show you, is there any new data loaded apart from 2023? I mean 1st March 2023. I mean 2024, sorry. So you see over here, after the 1st March 2024, you see one more new record is inserted. I mean few more records are inserted, that is 16 records on 2nd March 2024. So there are few new records which are there. So this becomes the delta changes and the data needs to be uploaded. As soon as I run this DAG, it will try to fetch from the last extract date the delta change. The 2nd February and the 2nd March data will be uploaded to S3 bucket. Meanwhile, let me show you what is there in the S3 bucket as well. So this is the path, S3 bucket path which is loading. Amazon, the bucket name is L6 Snowflake, Snowflake directory inside that database name and table name. Inside it we have file date partition path. Inside it we have the respective data. Okay, so before executing that, let me show you what is there in our source data, target data. That's nothing but Snowflake. So I have logged into the Snowflake UI and let me run this. So if you see over here, the data is there only till 1st March 2024. It has 15 records and this is matching with the source data, that is from MySQL database. So now let me run the DAG and show you. So DAG started. Now update data to S3 is running. Now the update data to S3 is successful. Now update of config also successful. Now the DAG is successfully completed. Yeah. Now let me first open and show you, did the config update in the source database, that is this particular query. So before, when I ran, it was 1st March 2024. Now let's see what it is. Now you see, now last extra date got updated, that is 2nd March 2024. Okay, the data got updated, the data got uploaded successfully, and on successfully upload, config got updated. So this, it remain as it is. So here we need to do a count check in the Snowflake. Now let's check in the Snowflake, did we get the data or not? So this is the Amazon books group by business date. Let me run this. Now you see over here, in the previous run we saw that we had data on it till 1st March 2024, that has 15 record. Now you see we have 2nd March 2024 having 16 records. So data got ingested successfully. And you see over here, if I refresh it, the data also loaded to S3 bucket successfully. Meanwhile, let me show you the Lambda point of view, Lambda function. So we had created a Lambda where I had created a Lambda layer where, because Snowflake connector is not pre-built, it's not installed, so we have to install the library and provide the Lambda layer to it. So in the Lambda layer, I had installed Snowflake connector, and pandas. Boto3 is inbuilt available as well as JSON, but pandas and Snowflake connector we need to install and provide it as layers. So I had given a Lambda S3 bucket trigger. As soon as a file is loaded to the specified path, this particular script is triggered, and you see this is the entire function. So I'm giving all the credential here itself, AWS credential, Snowflake credential, main data. So let me open this. Let me open my GitHub repository where I had uploaded the Lambda script. Let me show you. See over here, I just uploaded. We need to give, I have given here itself the AWS credential, Snowflake credential, main data. All the steps are done, as I said, getting the last extract, updating it, and merge into command is also running over here. Okay, detailed explanation I'll be giving in the next pipeline. Okay, so that is set. So this tag runs successful and data got loaded. Let me even run the total counts. Is it matching or not? From external table to see from Amazon book external table is 137, Amazon book also 137. So data count point of view it's matching. Let's try to check the data count from source as well. So let's see how much data is there in the source count. No, sorry, it's not this one. Yep, this one. So let's see what's the total count. Yeah, it's 137. See over here, it's 137. Same thing which is matching with over here in external table also, which is pointed to S3 bucket. That is also 137. Data got ingested to the final table, that is also 137. So this is where it is. I hope you liked it. Thank you.